In lesson 10.1, we're going to be talking about solids and the geometry associated with those. And one of the first things that we're going to talk about is something called a polyhedron. Now, a polyhedron is a solid formed by polygons that enclose a certain space. Here on our diagram that you see, we see a pyramid, and a pyramid is one type of polyhedron. The flat surfaces that we see around the surface are called faces, where we have two faces coming together. We have edges, and when three or more edges are meeting, they're called vertices. To see a lot of examples of these polyhedra, you can look in your book, I think it's page 505. So just as an example, as I look at what a face is, this yellow highlight here, and everything inside is one of the many faces in this pyramid. So those are the faces. We have edges where two faces are coming together. So for example, right here on the right side of that yellow triangle is an edge, because there is another face. If I look at the second face in green here, which is another triangle, those two faces are meeting at that edge. And then we also have vertices, and that's where three edges are coming together, or more. So we have vertices. Singular is vertex. Here's another example down here. We have edges. And one of the examples, the one I used, was where the two faces were coming together, the yellow and the green. And we have the faces, one highlighted in green and one highlighted in yellow. A prism is a polyhedron that has two bases that are congruent and parallel and polygons. So prisms, as you can see in our current picture, in this particular example here on the left, we have these two pentagons highlighted. They are the same size and shape, that's the congruent part, and they are parallel, so they would never intersect, and they are polygons. So those are our two bases. The other faces are called lateral faces. So an example perhaps of the lateral faces would be one of these rectangles that you see that are connecting the bases. And if you have more than one lateral face meeting, that's a lateral edge. So lateral edges would be when two faces come together, like for example, right here. There's a lateral edge highlighted in the green. And we have earlier talked about these lateral faces being rectangles. And if they are rectangles, then it's called a right prism. Now, a right prism might seem to you like the normal kind of prism. It's the one that stands straight up and down. Looks like it's vertical. If they are not rectangles, but instead they are parallelograms, then you actually have something called an oblique prism. And an oblique prism is like the one that's over here. It looks like it's tilted, like the Leaning Tower of Pisa. And a right prism would be one kind of like the IDS Tower in Minneapolis, straight up and down. And that's kind of the main difference. Don't forget that we had a special word a while back called altitude. Oftentimes we have used the word height. And don't forget that that means that you have right angles. In a right prism, we see that our altitude forms a right angle, and it's actually one of the edges of our lateral faces. However, in the right-hand figure, when we have an oblique prism, or in other words, one that's tilted, the height falls outside of that shape. And so this altitude or height, if you will, is outside of the prism, not along its edge. So something important to remember, altitudes have to be perpendicular. If it's a right prism, it's the edge. If it's not a right prism and it's an oblique prism, then the height will be outside. And oftentimes on a quiz or a test, they'll give you that measurement. In our next slide, we're going to be talking about pyramids specifically. And a pyramid has one base, and so if we look down below, we see that our base in this particular pyramid is a hexagon. So that's kind of something unique about a pyramid. There's only one base. The lateral faces are triangles. So when you look at the lateral faces, for example, here is a triangle for the lateral face, and all the faces meet at a common vertex, and that common vertex is the point of the pyramid. And as in the previous slide, the figure on the left side of our page is called a right pyramid, and the one that's on the right-hand side of our page is called an oblique pyramid. All pyramids are classified by the base. So in this particular example right here, this is a hexagonal pyramid. In this slide, we're going to be talking about a sphere and a hemisphere. So a sphere is a set of points that are a certain distance from a given point. That sounds very general. But basically what it's saying is if I put a point somewhere in space and I take a string and I move that string anywhere I want to in any direction, that would define my sphere. And every sphere, like circles, has a radius. And hemispheres are basically spheres that are chopped in half along the diameter. So when you look at our globe, as an example, is often considered to be a sphere, although it's not a perfect sphere. They talk about it as a sphere. And if you were to chop straight through and lift off half, then of course you'd have a hemisphere. You could do this with an orange, that kind of thing, a tennis ball. Any great circle is a circle that passes through the center of the sphere. So on our globe, a longitudinal line would be an example of that. In the picture down below, if I was doing a great circle, you can see one of them here outlined in brown. This is a circle that goes through the center. I could have also done one vertically if I wanted to. That looks like this. As you can see, it looks like the center of the circle is in the center of that vertical great circle. And then on the right, you see an example. I'm sorry, it's not very beautiful example, but it's an example of a hemisphere. My drawing tools, when I created these slides, were not very good, and so this should be much more of a smooth arc than that squiggly line. In the next slide, we talk about cylinders, and a cylinder has two bases that are parallel and congruent and are circles. And so we can see that as we look at our cylinder, there's one circle on the top, and there's another circle on the bottom, and they are congruent and parallel. And just like in our previous slides with other figures, this figure that I just shaded in is called a right cylinder because it is vertical and the height is also the altitude. And then on the right hand side of our slide here, this is an oblique cylinder because the height falls outside the cylinder, whereas in my previous one, my height is also inside my cylinder, and it's the altitude. In our very last slide here for this lesson, we're going to be talking about cones. And a cone has a base that's a circle, just like we had in a cylinder. The difference is that there's only one base in a cone, similar to a pyramid. But in pyramids, our bases were polygons, and in cones, our bases are circles. And in this cone, we notice that the vertex is the point that's the greatest perpendicular distance from our base. And so that vertex is here and here. And we also notice that on the left-hand part of the slide, we have a right cone. And that's because the line segment connecting the vertex and the base are perpendicular. And on the right side of our slide here, we have an oblique cone. Most people that I talk to just think about as a right cone as one that's up and down, and an oblique cone as one that's slanted. And as far as like a holistic way to think about it, that works out just fine. Notice that our altitudes, as in the past, for our right cone lie inside the cone, perpendicular to the base, but in the oblique, they're on the outside, perpendicular to the base.